Question 1. A large enterprise wants to ensure that all new Azure subscriptions provisioned for development teams adhere to strict corporate governance, including specific network configurations, mandatory tagging, and predefined security roles. They need a service that can bundle these elements into a reusable definition and enforce them consistently. Which Azure service is best suited for this requirement? Option A, Azure Resource Manager, ARM. Templates. Option B, Azure Policy. Option C, Azure Blueprints. Option D, Azure DevOps Pipelines. The correct answer is Azure Blueprints. Here's the explanation. Azure Blueprints is designed to define a repeatable set of Azure resources, enforce standards, compliance, and governance across subscriptions. It bundles ARM templates, policy assignments, and role assignments into a single, reusable definition, which is ideal for consistent environment provisioning and governance. Question 2. An Azure Administrator is creating a new Azure Blueprint definition to standardize the deployment of a new application environment. Which of the following are valid artifact types that can be included within an Azure Blueprint definition? Select all that apply. 1. Azure Resource Manager, ARM, templates. 2. Azure Policy Assignments. 3. Azure Functions. 4. Role-Based Access Control, RBAC. Assignments. 5. Resource Groups. Option A, 1, 2, 3, 4. Option B, 1, 2, 4, 5. Option C, 1, 3, 4, 5. Option D, 2, 3, 4, 5. The correct answer is 1, 2, 4, 5. Here's the explanation. The 4 core artifact types that can be included in an Azure Blueprint definition are resource groups, ARM templates, policy assignments, and role assignments, RBAC. Azure Functions are a compute service and are typically deployed via an ARM template, not as a direct blueprint artifact type. Question 3. A blueprint has been assigned to an Azure subscription with the "read-only" locking mode. A developer, who normally has contributor access to resources within this subscription, attempts to delete a virtual machine that was deployed by this blueprint. What will be the outcome of this action? Option A. The virtual machine will be deleted successfully because the developer has contributor access. Option B. The virtual machine deletion will fail, but the developer will be able to modify its settings. Option C. The virtual machine deletion will fail, and the developer will also be unable to modify its settings. Option D. The blueprint will automatically redeploy the virtual machine after deletion. The correct answer is the virtual machine deletion will fail, and the developer will also be unable to modify its settings. Here's the explanation. When a blueprint is assigned with a "read-only" locking mode, it prevents both deletion and modification of the resources deployed by that blueprint, even if the user attempting the action normally has sufficient RBAC permissions. Question 4. A production Azure storage account must be protected from accidental deletion, but administrators still need to be able to modify its configuration settings, e.g., change replication type, update access tiers. Which type of resource lock should be applied? Option A, read-only lock. Option B, delete lock. Option C, deny lock. Option D, prevent modify lock. The correct answer is delete lock. Here's the explanation. A delete lock prevents deletion of the resource but still allows read and modify operations. A read-only lock would prevent modification as well. Deny lock and prevent modify lock are not standard Azure resource lock types. Question 5. An Azure subscription has a delete resource lock applied. Within this subscription, a specific resource group, production-RG, has a read-only resource lock applied. A virtual machine, prod-VM, resides within production-rg. What is the effective lock on prod-VM? Option A, no lock, as the subscription lock is overridden. Option B, delete lock, inherited from the subscription. Option C, read-only lock, inherited from the resource group. Option D, both delete and read-only locks, with delete taking precedence. The correct answer is read-only lock, inherited from the resource group. Here's the explanation. Resource locks are inherited by child resources. In case of conflicting locks at different scopes, the most restrictive lock takes precedence. Read-only is more restrictive than delete, so the read-only lock from the resource group applies to prod VM. Question 6. A. Read-only resource lock has been applied to an Azure storage account named Critical Data SA. Which of the following operations is still permitted by this lock? Option A, deleting the Critical Data SA storage account. Option B, modifying the replication type of Critical Data SA. Option C, adding a new blob to a container within Critical Data SA. Option D, changing the access tier of Critical Data SA. The correct answer is adding a new blob to a container within Critical Data SA. Here's the explanation. Resource locks protect the times management plane of Azure resources: creation, configuration, deletion. They do not protect the time data plane. Adding, deleting, or modifying blobs within a storage account is a data plane operation and is not prevented by a read-only lock on the storage account itself. Question 7. Which of the following best describes the primary purpose of tags in Cloud Resource Organization? Option A, to directly modify a resource's operational configuration and behavior. Option B, to provide simple key-value pairs for logical grouping, management, and search of resources. Option C, to replace traditional hierarchical folder structures entirely. Option D, to serve as the sole method for enforcing network security policies. The correct answer is to provide simple key-value pairs for logical grouping, management, and search of resources. Here's the explanation. Tags are fundamental metadata elements, key-value pairs, used to logically group, manage, and search for resources. They do not directly alter a resource's operational configuration and complement, rather than replace, hierarchical structures. While they enable security policy enforcement, it's not their sole purpose. Question 8. An administrator is implementing a tagging strategy and defines a tag as environment, production. Which of the following statements is a critical consideration regarding tag keys and values in most cloud environments? Option A, tag keys and values are always case-insensitive for easier querying. Option B, the key, environment, and environment are typically treated as identical. Option C, inconsistent casing, like environment production versus environment production, can lead to resources being missed by queries. Option D, only tag values are case-sensitive, while keys are always insensitive. The correct answer is inconsistent casing, like environment production versus environment production, can lead to resources being missed by queries. Here's the explanation. Most cloud providers treat tag keys, and sometimes values, as case-sensitive. This means environment production is distinct from environment production, and inconsistent casing can result in resources not being correctly identified or included in queries, making consistency crucial for effective governance. Question 9. Which of the following are primary use cases for implementing a robust tagging strategy in a cloud environment? Select all that apply. Option A, cost allocation and chargeback. Option B, granular access control, IAM ABAC. Option C, direct modification of VM CPU and memory settings. Option D, operational automation, e.g., scheduled shutdowns. The correct answer is Cost allocation and chargeback B. Granular access control IAM, ABAC, D. Operational automation, e.g., scheduled shutdowns. Here's the explanation. Tags are critical enablers for cost allocation and chargeback by department or project, enabling granular access control through attribute-based access control, ABAC, and driving operational automation, like targeting resources for scheduled actions. Tags are metadata and do not directly modify resource operational settings like CPU or memory. Thanks for watching. Please subscribe to my channel.